Hey, what's up, folks? How we doing? This is Mr. Moray coming to you with a little video on radical and rational exponents, okay? So this is the beginning of our new unit that we just kind of launched into. And this is going to be a challenging unit, but I think if you can stick with me, and hopefully sticking with me is evidenced by you having access to this video, I think you'll find that this will be something that you'll actually kind of enjoy. And it's a new concept. We're going into unfamiliar territory, but believe me when I say that this stuff that we're doing follows, okay, from the stuff that we've already done last year, if you had me or if you didn't have me, right? So here we go. So just recall really quick, a rational exponent, and remember, when you see the word rational, think ratio, okay? A rational exponent is an exponent that is essentially a fraction, so a over b. Okay, and remember, when you have x to the a over b, okay, the b represents the index of a root, and the a represents the power. So the a does what it always has done. And if you think about it, before we even define the bottom, right, any number, any integer, any whole number is just itself over 1. So that's always just been as is. And now we're just adding on that denominator, okay? And it represents a root whose index is the denominator, b, and the power is a. Now, remember, we call the root itself the radical. We call what's the root is being done to, the thing in the root, the radicand. And we call the number that represents what root is it, the index. Okay, so the index is b. X to the a is the radicand, because that's what's being rooted, okay? And we talked about this little pattern, okay? If the index is an odd number, 1, and that keeps everything the same. So 3, 5, 7, 9, 11, those kinds of roots. And it's a positive number that we're taking the root of, we'll have one real solution. If it's an even number, this is what we spent a lot of time last year doing. Even power or even index, right? So like the square root, the second root, positive on the inside, there'll be two real solutions or two real values. If there's an odd index and a negative number, you'll have one real number or solution in there. And if it's an even index with a negative number inside, you're going to have two complex. Now, we opened the year talking about this, right? The even. We talked about how to do some quadratics by taking square roots last year, and maybe we touched on that this year, all right? But we had a whole unit kind of talking about, hey, how do we expand the real numbers into complex, where we use two complex solutions, all right? So that will come back, and I'll show you an example maybe in this video, though it's to be determined how deeply we dive into that, okay? So here's my example for you. I've got 8 to the power of 2/3. Now, when I say 8 to the power of 2/3, all right, what I mean is that the root is 3 and the exponent is 2. But remember what we talked about. Because of the laws of exponents, we could either see this as the cube root of 8 squared, that is 8 to the 1/3 to the power of 2, or 8 squared and the cube root of that, 8 to the second to the power of 1/3, okay? So what's really cool about it is when we see, all right, a rational exponent, we have sometimes two ways to do it. First, we could get the root and then raise it to the power of the numerator, or we could raise it to the power of the numerator and do the root whose index is the denominator, okay? Now, if you look at here, right, we do the cube root of 8, that's 2, and 2 squared is 4. Alternatively, we could do the 8 squared, which is 64, and 64's cube root is 4. Now, sometimes, okay, it's not going to always be that easy. Sometimes you're not going to be able to square it easily, but the third root will be really like right in front of you, smacking you in the face. For example, if I did 32 to the 7/5, the fifth root of 32 is 2, all right? But 32 to the power of 7, that's a really, really big number. We don't want to do that first. And if you think about it, if you actually back up and do the fifth root, you get 2. 2 to the 7th is actually 2, 4, 8, 16, 32, 64, 128, right? Your answer is going to be 128, but you're not going to be able to see that if you're doing like, wait a minute, 32 times itself, 7 times. That would be a lot of work. Let me show you how we do some of these. So I'm going to start you off with 216, and I'm just going to vary this up. I'm going to make it 1, and I'm going to make this to a positive, and I'm going to make this into a 2. Let me just get my little pencil here. I'm going to fix that up. So I'm going to make this to a plus. Oh, man. Okay, just my luck. And this to a 2. Okay? So 216 to the 2/3. Let's do this. So first, 216 to the 2/3. So I got two options, basically. I can square 216. 216 times 216. Huge number. And then take the third root. Or I can take the third root of 216 and then square it. Here's what I'm going to do. I'm going to actually, okay, I'm going to take the cube root first because I know I got 6 times 6 is 36. 36 times 6 is 216. So here's what I'm essentially doing. I'm going to do the third root first and then squared. Now, I'm going to be honest with you, all right? We talked in class. You can do this on a calculator, but we want to know how to do this without a calculator because eventually we're going to get into the letters. Calculator's not going to help you with that, all right? It will help you with the numbers, but not the letters. All right, so what I'm doing is, look, I'm doing the cube root of 216, and then I'm squaring it. Now, the cube root of 216, that's going to be 6. 6 squared is 36. Now, people have been like, Mr. Moray, how come there's only one answer? Remember, this is a cube root. Cube roots only have one value, okay? 216, the cube root, it's only 6. If it was like the fourth root and it was another number like the fourth root of 81, that's when you get like the plus or the minus 3. So be careful with that, okay? My next example for you is 16x squared to the negative 3 halves. This works just like the exponents always do. But remember, what do we do when we have a negative exponent? First, you got to put that thing in the denominator, all right? So first, I go 1 over 16x squared. Put that down there, all right? Now I make this thing a 3 halves. See, the exponent becomes positive. Let's take a little zoom in on that, all right? Positive exponent, see, goes in the denominator, becomes positive. All right, now, just like with any expression, you're going to do one thing at a time, right? So this is always how it worked. But this was one of the big misconceptions that we really hit at last year, right? So this is 16 to the 3 halves times x squared to the 3 halves, right? Because in this case, you're doing a product to a power. You got to do the first thing to the power and then the second thing to that power. So I got to do 16 to the 3 halves, all right? So in this case, I'm going to stick with the positive root. We do know that 16, you could actually get 2 answers with that, and we'll talk about that with the positive root. So technically, you could actually have 2 things coming out of here. Let's take a look at it. I'll actually show you both since I'm here. Now look, the square root of 16, we don't know for sure that that isn't negative 4 or 4. So look, we do the square root, it becomes 4. And then we do that, 4 to the third. So the 16 to the 1 half, giving us 4. 4 to the third, that's 64. Okay? Now, we do x squared to the 3 halves, right? So when you have a power raised to another power, those multiply. In this case, I get 2 to the 3 halves. The 2's cancel, and I get 3. So it becomes x cubed. And now I'm going to stick a plus or a minus in front of here. And the reason is because technically speaking, we don't know that that's 16 to the 3 halves. We don't know that's not technically not a negative 4, right? If you do negative 4, all right, you do negative 4, you cube negative 4, all right, and then you take it, you could actually end up getting the same answer on that one, right? Because think about it. If I do negative 4, I square negative 4, I'm still going to get an answer of 16. So you got to be careful there, all right? All right, so I'm going to make that a plus or minus for now, and we'll see what happens there, okay? But just remember, if you're going to do a square root, you could end up with more than one answer. For example, if I had done 16 cubes and then I squared it, I could have also had a negative number going in there. Now I'm going to hit this next one right here. 32 over x to the 10th to the negative 1/5. Same thing. First, give it a flip. Give it a flippity flip. So I do the x to the 10th. I drop the 32 down there, right? You got to flip it. You got to do the reciprocal. Then I'm going to make that power a positive 1/5. All right, now it's a quotient. So I'm going to do the power on the numerator and then the denominator, all right? So look, x to the 10th to the 1/5. We multiply the exponents. That becomes x squared. This is a fifth root, so it's going to have a unique solution there. I just circled this so we know this is different. Now, 32 to the 1/5. What number times itself, times itself, times itself, times itself is 32? That is 2, right? Because 2 times 2 times 2 times 2 times 2 is 32. So we get x squared over 2, right? So with a quotient, you're breaking it down one piece at a time. All right, last problem here. Challenge. Okay, so if any of these previous examples have been tough for you, I recommend you go back, you rewind, you watch me do it step by step, because what I got for you right now is a little challenge, all right? So here's what I need you to do. I need you to jump in, try to take a stab at this one. Let's keep the roots positive. Let's forget about the negative roots for a second. Say those don't exist. I want the positive root of this. I want you to answer this for me. Simplify this thing out. So I got 16x to the 8th to the 1/4 times 81 times x to the 16th to the power of negative 3/4. So go ahead, pause the video, do the individual things, multiply them together, okay? And then unpause and we'll see if you were right. All right, I'm excited for this one. So one thing at a time. Let's hit the 16 to the x to the 8th first. So we do one at a time. So 16 to the power of 1/4. That's like the fourth root of 16. So what times itself times itself times itself is 16. Remember, let's just keep it the positive one. 2. 2 times 2 times 2 times 2, that's 16. Now, x to the 8th, those combine, right? X squared. Okay? Now, this one, remember, this one's going to be a little fraction, 1 over, okay, 81 x to the 16th, okay, to the 3/4. It becomes a positive. Now, 1, that's not going to change anything, right? 1 to any power is 1, right? 1, the fourth root of 1 is 1. 1 cubed is 1. Doesn't matter. You're good. But let's take a look at this one, okay? So I got to hit this one up. Now, look, I could start by cubing 81. I could do 81, 81, 81. Then I could take the fourth root. Here's the thing. I don't want to do that because I can't multiply 81 times itself twice. That's too much. What if I do the fourth root? So what times itself, times itself, times itself, 4 times. 4 of them gets me 81. Let's say it's a positive. It's going to be 3. So I got 2x squared. All right, got 1 over 3. It technically could be negative 3 because negative 3 times negative 3 is 9, times negative 3 is 27, times negative 3 is 81. So technically, it could be negative 3. We're going to pretend it's just the positive one just for the sake of this video. Now I need to do x to the 16th to the 3/4. So the exponents multiply. I get x to the 12th, right? Because 3/4 of 16 is 12. Now I got this expression right here. I'll multiply across the top. That gets me 2x squared over 3x to the 12th. All right, and now I use the law of exponents, right? I got two x's up here, so I'm going to get 2 over 3x to the 10th. All right, now look, I know in class we have not done these combination problems yet, but think about it. This is just using the laws of exponents, all right, going one at a time. And that's all it is, right? It's a laws of exponents, but now I'm throwing in the idea that rational numbers like 1/4, 3/4, negative 3/4, a fifth, that those can be also exponents. Okay, so if you need me to go through that again, how I did that, I really want you to go ahead and rewind and do that. And then in a second, I'm going to go ahead and move on to the next set of problems. All right, so here I go. I am now going to move on to the next set of problems. All right, these are all radicals. So the other thing we got to work on is how do we simplify some of these radicals right here? So here's the idea. You want to take a close look at the root. One, what kind of root do I have? All right, is it a second root, third root, fourth root, fifth root? When I break down these radicals, all right, this was a really good idea suggested by someone in class today. They were like, what's up? Here's what you're going to do. You're going to use a tree. You're going to break it down so that one of the numbers in the tree has got a perfect whatever, a perfect square, a perfect cube, a perfect fourth, etc. So here's the deal. I love this, guys. Let's make a tree. All right, let's make a tree. Now, 162, okay, that's going to break down. I need to know, okay, what number is going to go into 162 that's going to have a perfect square. All right, so remember a couple strategies I told you. One, if the numbers add up, the digits add up to a multiple of 9, the number is going to be divisible by 9. Why do I care? Because 9 has a perfect square, okay? It's 3. So that's what you want to do. So now I'm thinking, all right, yes. So basically what I'm going to do is I know that 9 goes into this guy how many times? Let's see. Well, 9 goes into 16 once. Leaves a remainder of 7. 9 goes into 72 8 times. So what I know is that the square root of 162 is the square root of 9 plus or minus times the square root of 8. And because it's an even root, I'm going to drop my plus or minus up front. Now, the 9 becomes plus or minus 3. The 8 stays the same. Okay? Now, I come back through. Remember, like with the factor, I'm like, look, every step you go back through, you see if it's done. Let's go back through and see if it's done. 3, that's already out. 8, can I break down 8? Is there a perfect square that goes into 8? Yes, there's 4 goes into 8, okay? So what that tells me is that I could have gotten a bigger number to go into 162. That's a perfect square. As it turns out, 81 times 2 is 162. So that tells me that I could have done it another way. But here's the thing. As long as you get to the right answer in the end, that's all right. Now, I did make one little mistake here, and I got to figure out what mistake I made. Here's my mistake. It was actually supposed to be 18. Because 9 goes into 16 once, leaves a remainder of 7. Yeah, okay, so let's try it again, right? And I just want to check it. I got to do a sanity check, right? Because I do these things off the cuff sometimes. 72, okay, even a 7, 9, 16. All right, I feel better about this. All right, yeah, I was like, that didn't make sense. All right, so what I wanted, but now I look at 18. Either way, I got the same deal. All right, the 18's got a 9 in it again. I can see the 9 and the 2. All right, so I do the same thing, right? So the 9, it's equal to plus or minus 3 times the square root of 9 times the square root of 2, right? Because 9 times 2 is 18. Okay, again, you don't need to do another plus or minus. Times 3 times the square root of 2. I get 9 square root of 2 plus or minus 9 square root of 2. Don't forget your plus or minus. I'll make that clear there. Now, let's say I had seen that this was equal to 81 times 2 from the jump. All right, I would have gotten plus or minus 9 square root of 2. So the thing with these root problems is there's often more than one way to get the correct answer. Okay, and just because you didn't get the correct answer the same way I did does not mean that your answer is not correct. It just means you took a different solution path. But if you can get to plus or minus 9 square root of 2 in a completely valid way, then you're going to get full credit. It's not about saying, hey, Billy didn't get it the same way I did. Billy's wrong. It's about saying, hey, did Billy get the answer in a way that makes sense. That's what I want to see, okay? Okay, it's not about did you get it in the right way. It's not about did you get it in the same way as me. It's about did you get it in a way that makes sense, okay? And I hope that that makes sense to you, because I'm not looking to call people out. I'm not looking to make you feel bad about the way you do things. I want you to show me, okay, that you're capable of doing the math. That's what matters to me. All right, so here we go. I want to now look at this. The cube root of 243 times, or rather negative 243 times 5. Okay, notice I put that 5 in front just for a little extra challenge. Okay, I want to know what was going on there. So this is what we got here, and I need to figure out how do we solve this. So what I'm doing is I'm looking inside of the cube root, and I'm seeing, can I break down negative 243? So I'm looking for a number that goes into 243, okay? That's or that is a cube root. That's going to be extremely important. So I need to know, this is where it gets into, you need to be really good with your perfect cubes, okay? So I'm thinking, and I happen to know in this case that I believe 27 goes in here, all right? Because here's the deal. 270, okay, times 9. Let's see what that is. Let's come up here. Let's do 27, rather 27. Oh, but 27 times 9 is not going to work because 9, oh, maybe it will. Maybe it will. Let's see. All right, so 9 times 7, that's 9, 18, 27, 36, 40, 54, 63. Okay. Carry the 6. 9, 18, 19, 20, 22, 23, 24, 2. Sorry, this is 3. 3, carry the 6. See? It's not easy stuff. All right, so what you get is 243, and you can check that on your calculator. So here's what I know. I know the cube root is basically this. I can get this to break down. Now, this is an odd root. So when you have an odd root, you want to get the perfect cube. You want to have the perfect cube be negative. 27, negative 27 is negative 3 times negative 3 times negative 3. So I'm going to get my cube root in there. Times 9, which does not have a perfect cube, and that's all right. So what I got is, now you always want to rewrite after every step. That's the Jordanian rule, after my friend Mr. Jordan, all right? So we got 5 times the cube root of negative 27 times the cube root of 9. Those are equivalent, okay? Now, let's simplify. 5 times negative 3 times the cube root of 9. Now I bring the 5 and the negative 3 together. It becomes negative 15 times the cube root of 9. And that's all I got. Now, why is there not a plus or minus, Mr. Moray? Because it's an odd index. And an odd index only has one possible answer, okay? Because it's odd. It's going to be multiplied an odd number of times, okay? So, noticing. Let's go back here, right? So, negative 3 times negative 3 times negative 3 is 27, negative 27. Negative 27 times 9, we now know is negative 243. So that establishes why negative 3 times the cube root of 9 is negative 243. And then I multiply it by the 5 that's there. Don't forget about to multiply it by the 5 that's outside of there. All right, so if any of this has been challenging for you, I really highly recommend you go back and take another look. But in a moment, I am going to move on to the next part of this. All right, so now I'm going to do 1,000 times the x to the power of 9. So what we learned is this. We said, look, you look at the power on the x, and we said, hey, here's the deal. If the power on the variable, the exponent, is divisible by the index, that is, if 9 is divisible by 3, we simplify it. We do that division, it becomes a new whole number, we pull it out of the root. Otherwise, if it is not, we just leave it in the root. Let's see what that looks like. So look, I'm going to break this up. This is So I always say break every piece up. So first, I'm going to do the cube root of 1,000. Then I'm going to multiply by the cube root of x to the 9th. So now, either 1,000 will not break up at all, it will break up into a whole number, or it will break up into a whole number times a root. In this case, I know that 10 times 10 times 10 is 1,000. So I know that's going to become a 10. And then I come to the x to the power of 9. Is 9 divisible by 3? It is. So the x, you multiply, you divide basically by 3, because this is x to the 9th to the 1/3. So you're multiplying the exponents, 9 and 1/3, or you're dividing the exponent in the root by the index of that root. So it becomes 10 times x cubed. Let's think about it. 10 times 10 times 10 is 1,000. X cubed times x cubed times x cubed is x to the 9th. Because remember, when you multiply x cubed times x cubed times x cubed, you're adding the exponents because the things are being multiplied. All right, now I'm going to look at another example. Notice, what's the index here? The index is 2. Remember, when you don't see an index, it's always 2. I'm going to come here. Now, whoa, I need to figure out, wow, 242. So let me think. Well, here's what I'm going to do. I'm going to pull the 3, leave it. Okay? I'm going to do the square root of 242 times the square root of x to the 4th times the square root of y to the 7th, okay? 242, is it a perfect square? No, but 242 happens to be 121 times 2. Here's what you know. When you're doing 121, think about it. 1 times 2, 2. 2 times 2, 4. 1 times 2, 2. Okay? X to the 4th, we can square that. That's x squared. Y to the 7th, we got to leave it. We can't touch that, okay? So here's what happens. I drop these roots in because 121 times 2 is 242. So therefore, the square root of 121 times the square root of 2 has to be the square root of 242. So here I go. This is 11, so I have 3. And now I drop my plus or minus in because I'm doing a root. Times 11 times square root of 2 times x squared times root y to the 7th, right? That's not divisible by 2. I can't touch it. Now I use that commutative property. I bring everything in. So I have plus or minus 33 x squared, right? I do the 3 times 11 times the x squared. Then anything in the root, 2y to the 7th. Anything that's in roots, pull back together, bring into the root, right? Because look, think about it. The square root of 121 times the square root of 2 is the square root of 242, right? Those things multiply. So therefore, the square root of 2 times the square root of the y to the 7th is just the square root, boom, of 2y to the 7th. Okay, you can bring those things in. Remember, though, I'm looking to see for full credit, especially if I'm asking you to simplify a root, okay? I'm looking for you to know that you have to have 2 roots because the index is even. Now, let's try one with a 4th root. Yes. So look, same idea. Let's break it up, all right? 4th root of 16 times 4th root of x to the 16 times 4th root of y to the 20. Let's take a look. Does 16 have a perfect 4th? It does. It's plus or minus 2. So the plus or minus is taken care of. Now, look at the index. Look at the power. This will work if 16 is divisible by what number? I'll zoom in so we can see. 16 has to be divisible by what number? Based on the index of the root, needs to be divisible by 4. Okay? So I do times, is it? Of course. So I do x to the 4th. I bring that down. Now, 20 needs to be divisible by what? 20 needs to be divisible by what? In order for it to simplify and stay outside of the root, it has to be divisible by 4. Is 20 divisible by 4? Yes. So it becomes y to the what? To the 5th. Okay? And it's positive or negative because, again, we have a situation, okay, where it is an even index. All right, next one. Look, guys, I really believe in you. I want you to try this. Look at this one here. So I want you to do this. I want you to pause the video. I want you to try this one, okay? And then in a second, unpause, and I'll show you what the answer is. All right, let's get at it. So here's what we got. We're going to break this up piece by piece, all right? So drop in my 6, all right, times the cube root of negative 125, okay, times the cube root of x to the 17th, okay, times the cube root of y to the 21. Now, here I go. Does negative 125 have a cube root? Yes. Okay, so I'm going to do 6 times, what's the cube root of negative 125? It's negative 5, all right? This, can I do this? Can I do the 17 with the 3? I cannot, because 17 is not divisible evenly by 3. So the x to the 17 stays in the root. How about y to the 21st? Is 21 divisible by 3? It is. So this 21, what does it become when I pull it out of the root? Becomes y to the 7th, okay? So let's clean this up. Last step. Negative 6 times negative 5, that's negative 30. y7 comes in, and I leave my cube root of x to the 17th, okay? You could technically write it as x to the 17 thirds. I would accept that as an answer because they are, in theory, the same thing, right? This is x to the 17 thirds because we have a cube root. In this case, I will let you do it either way, but if I do change my mind or things change down the line, I'll let you know about that, okay? So I hope you got that one right. If not, go back and review this one. This one's a little trick right here. I thought this one was pretty tricky. I thought I was getting kind of trickster with it. Look, we have x plus 2y to the 12th and the 4th, right? But look, this is just this. Now let's convert it to a little let's convert it to a little exponent, okay? So this is x plus 2y. What is the exponent on this guy? 12. What is the index on the root? 4. So look, we can clean this up. All right, we can clean this guy up, right? This is x plus 2y to what power? To the power of 3. Okay, I'm actually cool if you leave it like that. You can expand it out. I'll let you know if I want you to expand that out. But you could do that if you wanted. The only thing is, what did I miss, guys? Technically speaking, okay, even though I knocked it down to the power of 3, I really want to put the plus or minus in there because, all right, if I have an even root, I technically do need to consider that plus or minus could be a possibility. So I want to think about that. Okay, last one. The 4th root of, all right, this thing right here. By the way, this is why I would do this. Because look, if this was a negative, you do it to the power of 12, it's going to become a positive, okay? So, because the negative will go away. So, last one. So, guys, here's the thing. I got a negative under that root. It's a 4th root. In theory, we should get a complex number, okay? I'm not going to show you how to get the complex just yet. I don't think we're there, but we're going to get there eventually. What I want you to do is pause the video, try to clean this up as much as you can, and then when you're ready, unpause, and we'll jump into it and take a look. All right, here's the thing. Not too much we can actually do to clean this one up, believe it or not. So the 2,500 actually does break down because 5 times 5 times 5 times 5, that's 625. But you can't make it a negative because remember, negatives aren't going to have real number 4th roots. 625 times what is 2,500. 625 times 4, because 600 times 4 is 2,400. This you can actually try to deal with. And what I'm going to do is this. I'm just going to hit the other ones with a negative, right? So this is the 4th root of 625 times the 4th root of 4 times the 4th root of x to the 13 times the 4th root of y to the 21. Then watch what I do. I'll just stick the negative in. Or you know what I could even do? I can't really do the 4th root. You know what I'll do? All right, I'll show you what I mean. I'll leave this as a 13, and I'll just multiply it by the 4th root of -1. We don't know what to do with that right now, so I'm going to leave it as is. So 625, here's what I got. 625, that's going to become a plus or minus 5, because plus 5 times 5 times 5 times 5 is 625, but -5 times -5 times -5 times -5, also 625, all right? Now, these, can I touch this? No. Can I touch this? What do we think? 13 and 4? No. The 13 does not go into 4. 21 and 4. Can that work? No. 21 doesn't go into 4. -1. We don't know how to do that, right? So in this case, we have not talked about how to do the complex. For right now, I'm kind of building up the skills. I'm not going to touch that just yet in this video. Maybe that will happen in a subsequent video. So all I can do right now is drop my 4th root in there and put whatever I have left. So I'll put my -1. I'll drop my 4. All right, I'll drop my x to the 13th. I'll drop my y to the 21st. So look, it's basically like this. You clean up what you can, you leave what you can't. That's this idea was the same with square roots, and it's going to continue. So what I want you to know is, guys, this stuff is not easy. I totally feel you on that. Here's the thing. You gotta believe me that so many of the things we're doing directly follow from things we've done before. Look, the hard thing here is that the roots are bigger roots. So the numbers we're looking for, 625. Let's see, 4. Let's see, 243, -27. Okay, they're just more complicated numbers. But the idea of multiplying two roots together, okay, to get a bigger root, nothing's changed about that. That idea remains the same. So if you believe in me, if you can stick through this with me, then I promise you can be successful, okay? So I hope you found this video to be helpful. I really recommend you take a look at some of that practice that I distributed, that practice worksheet. I assigned the front side originally. Take a look through that. Try to work through the letters, try to work through the numbers, split them up, bring them together like I discussed. And if you have questions, feel free to send them my way. But remember, no matter what, don't forget that you can do it, okay? So I hope you enjoyed this video. Keep at it, keep sending me those good questions, and don't give up. Have a wonderful day.